Hello friends, welcome to this YouTube channel. Today we shall solve a couple of numerical problems on three-phase induction motors. By solving these numerical problems, we shall learn how to determine different losses of a three-phase induction motor. We shall also learn how to determine input power and output power of a three-phase induction motor and thereby calculate its efficiency. Problem number 1. A three-phase induction motor running with a slip of 4% takes full load input power of 40 kilowatt. Neglecting stator losses, we have to determine the full load copper loss and the total mechanical power developed. Let us first jot down the given data. Full load input power P in equals to 40 kilowatt. Full load slip SFL equals to 4%, that is equal to 0.04. When we neglect stator losses, air gap power Pg is approximately equal to P in, that is equal to 40 kilowatt. Full load copper loss P copper equals to SFL times Pg, that is equal to 0.04 into 40, that gives us 1.6 kilowatt. Total mechanical power developed Pm equals to Pg minus P copper, that is equal to 40 minus 1.6, that gives us 38.4 kilowatt. Problem number 2. The power input to a 4-pole 3.3 kilovolt 50 Hz three-phase induction motor running at 1440 rpm is 80 kilowatt. The stator losses are 6 kilowatt and total friction and windage losses are 5.4 kilowatt. We have to determine the efficiency of this motor. Let us first jot down the given data. Supply frequency F equals to 50 Hz. Number of poles P equals to 4. Speed of induction motor Nr equals to 1440 rpm. Power input P in equals to 80 kilowatt. Stator losses PS equals to 6 kilowatt. Friction and windage losses PFR equals to 5.4 kilowatt. Let us first calculate synchronous speed of this induction motor. Ns equals to 120 F by P. Using values, we get 120 into 50 divided by 4. That gives us 1500 rpm. Slip S equals to Ns minus Nr divided by Ns. That is equal to 1500 minus 1440 divided by 1500. That gives us 0.04 or 4%. Air gap power Pg equals to P in minus Ps, that is equal to 80 minus 6, that gives us 74 kilowatt. Let us now calculate total rotor copper loss. P copper equals to S times Pg, that is equal to 0.04 into 74, that gives us 2.96 kilowatt. Total mechanical power developed Pm equals to Pg minus P copper. Using values, we get 74 minus 2.96, that gives us 71.04 kilowatt. Shaft power PO equals to PM minus PFR, that is equal to 71.04 minus 5.4, that gives us 65.64 kilowatt. Let us now determine efficiency. Eta equals to PO divided by Pin, that is equal to 65.64 divided by 80, that gives us 82.05%. Problem number 3. The shaft power output of a 3-phase 4-pole 50 Hz induction motor is 32 kilowatt at 1420 RPM. Total stator copper losses are 750 watt and stator core losses are 1020 watt. Friction and windage losses amount to 1.5% of shaft output power. We have to determine the rotor and stator input power. Let us first jot down the given data. Supply frequency F equals to 50 Hz. Number of poles P equals to 4. Speed of induction motor NR equals to 1420 RPM. Output power PO equals to 32 kilowatt. Stator core losses PIS equals to 1020 watts. Stator copper losses P copper S equals to 750 watt. Friction and windage losses PFR equals to 1.5% of PO, that is equal to 0.015 into 32, that gives us 0.48 kilowatt. Let us now calculate synchronous speed of induction motor. Ns equals to 120 F by P, that is equal to 120 into 50 divided by 4, that gives us 1500 RPM. Slip S equals to Ns minus Nr divided by Ns, that is equal to 1500 minus 1420 divided by 1500, that gives us 0.0533 or 5.33%. Mechanical power developed PM equals to PO plus PFR, that is equal to 32 plus 0.48, that gives us 32.48 kilowatt. Let us now calculate rotor input power or air gap power. Pg equals to Pm divided by 1 minus S, that is equal to 32.48 divided by 1 minus 0.0533, that gives us 34.31 kilowatt. Total stator losses PS equals to PIS plus P copper S, that is equal to 1020 plus 750, that gives us 1770 watt or 1.77 kilowatt. Let us now calculate stator input power. Pin equals to Pg plus Ps, that is equal to 34.31 plus 1.77, that gives us 36.08 kilowatt. Problem number 4. A 50 bhp 3-phase induction motor has full load efficiency of 84%. At full load, the rotor and stator copper losses are both equal to the core loss, while mechanical losses are 1/3 of the core loss. We have to determine slip of this motor. Let us first jot down the given data. Output power PO equals to 50 bhp. Since 1 bhp equals to 746 watt, PO equals to 50 into 746. That gives us 37,300 watt or 37.3 kilowatt. Given full load efficiency, eta FL equals to 84%, that is equal to 0.84. Since frequency of rotor induced EMF is very small, rotor iron loss is negligibly small. Therefore, we consider only stator core losses. According to the problem statement, the rotor and stator copper losses are both equal to the core loss. Therefore, we can write stator core losses PIS equals to P copper S equals to P copper R, where P copper S and P copper R are copper losses in stator and rotor respectively. According to the problem statement, mechanical losses PFR equals to 1/3 of PIS. Let us now calculate total power input. P in equals to PO divided by eta FL, that is equal to 37.3 divided by 0.84, that gives us 44.405 kilowatt. Total power losses P losses equals to P in minus PO. Using values, we get 44.405 minus 37.3, that is equal to 7.105 kilowatt. Again, expression for total power losses, P losses equals to PIS plus P copper S plus P copper R plus PFR. Using relationships, we get P losses equals to 10/3 PIS. Therefore, stator core losses PIS equals to 2.1315 kilowatt, that is equal to P copper S equals to P copper R. Total stator losses PS equals to PIS plus P copper S. Using values, we get 2 into 2.1315, that gives us 4.263 kilowatt. Air gap power PG equals to P in minus PS. Using values, we get 44.405 minus 4.263, that gives us 40.142 kilowatt. Since P copper R equals to S times PG, slip S equals to P copper R divided by PG. Using values, we get 2.1315 divided by 40.142, that gives us 0.0531 or 5.31%. Problem number 5. A 25 kilowatt 3-phase 4-pole 500 volt 50 Hz induction motor has full load speed of 1440 rpm. Total mechanical losses are 2 kilowatt. The motor operates at full load power factor of 0.8. We have to determine at full load slip, rotor copper loss, total input power if stator losses are 2.2 kilowatt, efficiency, line current and frequency of rotor induced EMF. Let us first jot down the given data. Supply voltage V equals to 500 volts. Supply frequency F equals to 50 Hz. Number of poles P equals to 4. Power factor cos phi equals to 0.8 lagging. Speed of induction motor NR equals to 1440 RPM. Shaft output power PO equals to 25 kilowatt. Stator losses PS equals to 2.2 kilowatt. Mechanical losses PFR equals to 2 kilowatt. Let us first calculate synchronous speed of this motor. Ns equals to 120 F by P, that is equal to 120 into 50 divided by 4, that gives us 1500 RPM. Slip S equals to Ns minus Nr divided by Ns, that is equal to 1500 minus 1440 divided by 1500, that gives us 0.04 or 4%. Frequency of rotor induced EMF Fr equals to S times F, that is equal to 0.04 into 50, that gives us 2 Hz. Mechanical power developed PM equals to PO plus PFR, that is equal to 25 plus 2, that gives us 27 kilowatt. Let us now calculate air gap power. PG equals to PM divided by 1 minus S, that is equal to 27 divided by 1 minus 0.04, that gives us 28.125 kilowatt. Rotor copper loss P copper equals to S times PG, that is equal to 0.04 into 28.125, that gives us 1.125 kilowatt. Total input power P in equals to PG plus PS. Putting values, we get 28.125 plus 2.2, that gives us 30.325 kilowatt. Let us now calculate efficiency. Eta equals to PO divided by P in. Using values, we get 25 divided by 30.325, that gives us 82.44%. Line current drawn by the motor IL equals to P in divided by √3 times V cos phi. Using values, we get 30.325 into 10 to the power 3 divided by √3 into 500 into 0.8. That gives us 43.7704 ampere. So today we have solved a couple of numerical problems on three-phase induction motors. By solving these problems, we have learned how to determine different losses of a three-phase induction motor, how to determine its input power and output power, and also its efficiency. Hope this lecture has been useful for you. If you have any suggestion or question, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.